One Friday evening in 1992, a meteorite ended a more than 150 million-mile journey by smashing into the trunk of a red Chevrolet Malibu in Peekskill, New York. Nearly 30 years later, a new analysis of that same Peekskill meteorite and 17 others by researchers at the University of Texas at Austin and the University of Tennessee, Knoxville, has led to a new hypothesis about how asteroids formed during the early years of the Solar System. The meteorites studied in the research originated from asteroids and serve as natural samples of the space rocks. They indicate that the asteroids formed through violent bombardment and subsequent reassembly, a finding that runs counter to the prevailing idea that the young Solar System was a peaceful place. The study was published in print December 1 in the journal Geochimica a Cosmochimica Acta. The research began when co-author Nick Dygert was a postdoctoral fellow at UT's Jackson School of Geosciences studying terrestrial rocks using a method that could measure the cooling rates of rocks from very high temperatures, up to 400 degrees Celsius. This is a really powerful new technique for using geochemistry to understand geophysical processes, and no one had used it to measure meteorites yet, Dygert said. Since the 1970s, scientists have been measuring minerals in meteorites to figure out how they formed. The work suggested that meteorites cooled very slowly from the outside inward in layers. From around 900 degrees Celsius down to 500 degrees Celsius, cooling rates were 1,000 to 1 million times faster than at lower temperatures. How could these two very different cooling rates be reconciled? The scientists proposed that asteroids formed in stages. If the early Solar System was, much like the old Atari game, Asteroids, rife with bombardment, large rocks would have been smashed to bits. Those smaller pieces would have cooled quickly. Afterward, when the small pieces reassembled into larger asteroids we see today, cooling rates would have slowed. To test this rubble pile hypothesis, Jackson School professor Mark Hess and first-year doctoral student Jialong Ren built a computational model of a two-stage thermal history of rubble pile asteroids for the first time. Because of the vast number of pieces in a rubble pile, 10, 15 or 1,000 trillions, and the vast array, one implication is that cooling slowed so much after reassembly not because the rock gave off heat in layers. Rather, it was that the rubble pile contained pores. And that's sort of unintuitive. Tim Swindle of the Lunar and Planetary Laboratory at the University of Arizona. The jury is still out. But this is a strong argument. The biggest implication of the new rubble pile hypothesis, Dygert said, is that these collisions characterize. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.